Okay, so today we are starting the binomial theorem. And in walking around the room, most of you figured out the pattern. If not, somebody near you did, and you had a great conversation and you figured it out. Let's start with the easiest. What runs down the outside? Ones. So let me go ahead and put some ones there. Let me see where the pen, there's the pen. All right. So, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, how do I figure out these other numbers, like the one that goes there? Add what? Be more specific. The two blocks, the two hexagons that touch. So 1 and 3 touch, and they make 4. And 3 and 3 touch and make 6. And 3 and 1 touch and make 4. This is known as Pascal's triangle. Okay, what's the next row going to be? 1, 5, 10, 10, 5, 1. Okay? 6. Okay? 7. Okay? Great. This is going to help to make life easier. Okay? So, I want you, up in the corner, you see the C40, okay? All right. I'm going to tell you what the 4 and the 0 represent in a second. For right now, C is combination. Combination is a type of probability, okay? And normally we teach the probabilities, but now we're kind of using a new curriculum and going in a different order. So, I would like you to pick up your calculator, okay? If you have one of my calculators, it's going to be super easy, okay? If you have a graphing calculator, I'm going to tell you the directions in a second. So everybody, regardless if you have one of mine or a graphing, press the number 4. Okay? If you have one of my calculators, after the 4, you're going to hit the PRB for probability. PRB for probability. Okay? It's in the second row. Okay? Now, if you have a graphing calculator, I need you to listen. You're going to press math, and you're going to arrow over to PRB. You're going to arrow over to PRB, probability. Okay? Now that everyone's at PRB, we want the C. So select the C, the NCR.
And then I press enter.
And then press, yes. Go ahead and press enter to select it, and then type in a 0. Yep, select it, and then type a 0. So it should say 4 NCR 0. Okay, if yours does not say that, let me help you. Beautiful. Hit enter. So you had to type 4 first.
Oh.
Math, probability. Oh, sorry. Okay, and what do you get? 1. Okay, can you go ahead and try to figure out how to do 4C1 in your calculator? Now, if you have my little calculator, I'm going to show you a cheat. You can press the up arrow and type over the 0 with a 1. Okay, and complete the chart at the top for me. Okay? Okay, so let's go back to your warm-up. If I can have everyone's attention again, let's go back to your warm-up. You had to look for a pattern. Now raise your hand if for this week's quiz you would sit there on your quiz and try to recreate that in the top corner to be able to pass your quiz. Raise your hand if you'd like to do that. You'd like to, no, like, I don't give you any of this. You have to remember how Pascal's look, and you write it up in the corner of your test. Would that be helpful? No. So I'm showing you how this came about and how to do it a different way. Okay, I'm going to show you some shortcuts that link back to this. Okay? All right. So 4C0 was 1, 4C1 was 4, 4C2 was 6, 4C was 4, and 4C4 was 1. Can you relate that anywhere? this row right here, right? Okay? How many rows is it? It's not the fourth row. It's the fifth row. We're going to talk about why it's the fifth row in a second. Okay, so then what's this one going to be? 1, 5, 10, 10, 5, 1. Okay? So rather than recreating this design, Pascal's triangle, you can type the code in. So let me better explain the code. Let me move this out of the way for a second. So the 4 is going to be my power, and the 0 is my term. By term, I mean first term, second term, third term, fourth term, fifth term. Okay? Or actually, no, let's scratch that. This is your overall power. This could be your term or your specific power. Overall power and specific power. Okay? Copy that down. I have another. So look at your new paper. All right. So the top row of Pascal's, and I'm going to be going back and forth, so you want both papers on your desk, okay? So this top row is x to the 0th power. The next row is x to the first, x to the second, and so forth. Okay? All right? A to the 0 is the top, a to the first, a to the second. Okay. Now, okay, so we're back to the first paper. Okay? Anything the power of 0 is 1. So I don't have to do FOIL for this one or anything, right? Anything the power of 1 is itself. Great. So x plus y. What happens when I have an x plus y squared? What do I have to do? But I have to do x plus y times x plus y, right? And then I have to FOIL. Okay? So that gets me x squared plus xy plus yx plus y squared, which is x squared plus 2xy plus y squared. Yes? I FOILed it back from algebra. Yes, I did FOIL from algebra. So I did x times x and got x squared. X times y is xy. Y times x is yx. Y times y is y squared. I combine the xy and the yx because they're the same thing, because 3 times 4 is the same as 4 times 3, and I got 2xy. Yes? Very tedious, right? Let's make it even more tedious. What if it was x plus y to the 3rd power? What would I have to do? I would have to do x plus y times x plus y times x plus y. So I would literally have to take what I just did, which is this first part, and multiply each one of them by x and then each one of them by y and combine like terms. Yes? Do you want to sit through that? No? Okay, well, I can tell you right now, the answer is x squared plus 3xy plus 3y. No, something's wrong. Sorry, x cubed, x squared, xy squared plus y cubed. Okay. So, I'm going to show you a shortcut. Okay? Okay? All right, so for right now, you're either using Pascal's triangle or use your calculator. Eventually, you're going to use your calculator because you're not going to sit for every quiz and try to recreate Pascal's triangle, right? Okay, we're at paper number 2. Back to paper number 2, this paper here, right? So, this was a 2, correct? Okay. I'm going to tell you that this is a 3 and a 3. Oh, you jumped right in and told me 4, 6, 4. How did you get that? I'm using Pascal's triangle. Now these, remember, this has a 1, but I don't have to write a 1. It's understood. If I have an x, it's 1x, right? Okay, so what number would go here? 5, 10, 10, 5. Okay, we are doing much better with our patterns today. Nice job. Okay, go ahead. 6. Okay, so you have the coefficients down. You have the coefficients down. I'm going to give you 30 seconds. I want you to look over an entire row. Look over an entire row. Pick a row and tell me what other patterns you notice. I'm going to give you 30 seconds. What other patterns? Okay, so let's talk. If I want these numbers in the box, if I want these numbers in the box, right? So I would look at this power here, and the code for this row, would have been 3C0, then 3C1, then 3C2, then 3C3. And that's how I got my 1, my 3, and my 1. Okay? That's why you don't have to memorize Pascal's triangle. Okay? So the overall power, and then we go 0, 1, 2, 3, 4, or whatever. You go from 0 until the power matches the power. Does that make sense? So if it's a 4, then the last one would be 4, 4. Okay. Now, what pattern did you notice elsewhere? Like this started at a 4. What do you notice in this row here? It starts with the 4. Then what happens? Just looking at the A, what happens? It gets less. It subtracts by 1, where the other one goes up by 1, right? Okay, so this is a 3 and a 1. This is a 2 and a 2, a 1 and a 3. What do you notice about the powers for each item? They're switched. Okay, yeah, they're switched. There's something else significant. 1 goes down, 1 increases. Yes, but what do you notice about 3 and 1, 2 and 2, 1 and 3? They add up to 4. Your powers will always add up to your overall power, if you need to jot that down. Your powers will always add up to your overall power. So if I have a power of 5, and my first term is 3, the second term is going to have a power of 3, because the overall power was 5. So 2 and 3 makes 5. Cool? So I am about to show you how I can do to the 7th power super fast. Now, if I didn't have Pascal's triangle, I have Pascal's triangle in front of me, so that makes life easier. But if I didn't, I would do 7C0, 7C1, 7C2, 7C3, all the way to 7C7, yes? Would you help me out and call out Pascal's triangle for 7? What is it? 1, give yourself some space. 7, 21, 35, 35, 21, I wrote too big, 7, and 1. So sorry, mine loops around because I wrote real big. That's the first thing I do. I write down my Pascals, my important Pascal numbers. If you want to write down steps, you can. First thing I do, I write down Pascal's important numbers, okay? Now, there are 2 pieces. Piece 1, piece 2. I start with piece 1 and it decreases, and then I'm going to come back the other way and decrease. Okay, so here we go. Let me do a different color. So I would like green. So I'm going to start with A to the 7th, A to the 6th. Come on. A to the 5, A to the 4, A to the 3, A to the 2, A to the 1st, A to the 0 doesn't matter. If you feel better Write it as a to the 0. A to the 0 is really 1, and when you multiply by 1, you don't change a number. Feeling good? Okay, so what was my next letter? It is B. So I'm going to start with B to the 7, B to the 6, and go the other way, right? B to the 5, B to the 4, B to the 3, B to the 2, B to the 1, no B to the 0. Now, addition's great. Addition, everyone gets addition. Does anyone know what would happen with subtraction? It alternates, yeah? So you have positive, negative, positive, negative, positive, negative. Okay? So I'm just going to write plus signs right here. Bam, bam. And this is called expanding. This is polynomial expansion. Okay. Cool. Binomial expansion. Yes? Good? All right. Yes, feeling good? Not so bad, right? Okay. So the next one is to do it with the power of 8. We're not going to do that. Okay? We don't have a lot of space. Okay. So I'm going to double check. These powers should add up to 7. Great. So now we're going to do a tricky think with your brain problem, okay? All right. So I'm going to try it one way and then another. I did 2 styles. That's why you have 2 sheets. Whatever way works with you, okay? So we're going to go back to the original paper. I am at this problem right here. Okay? Are you ready? I'm going to show you how you can do this problem in less than a minute, and you have to do minimal work, but you got to focus. Are we ready? Minimal work. Okay. My x is to the power of 7. Who can tell me what the power of my y is going to be? Who's been paying attention? I heard 15, I heard 8, I heard 21. How? Justify. Why are you saying 8? It has to add up to this, 15. So if I've already used up 7, how much is left? 8. Y is to the 8. Now they want the coefficient. So they want the number out front. Okay, I'm going to go. This is going to be scary. You ready? What's the overall power? 15. What's the power of the first term? 7. What's my coefficient? Put out those calculators. What's my coefficient? Come on, pull out those calculators. Unless you want to do 16 rows of Pascals, because 15 is the 16th row. What is it? Bam, you did it. Was it that scary? Yes? All right, then let's look at it a different way. Are you ready? Okay. Let's go to this other paper. All right. To find the coefficient. This one was nice. They already did the terms for us, yes? You can simply type power, first power. So what's my overall power? 5. What's my first power? 3. What's my coefficient? 10. Okay? You just need to be able to write the code and let the calculator do it for you. 3 is the first exponent I see in the term. Okay? That's where that came from. And the 5 comes from the overall power. Yes? Okay. When I type this in my calculator, this is the answer I get. Good question. Okay. Now, I want you guys to look at the row that goes 1, 4, 6, 4, 1. Yes? On Pascal's triangle. I don't care what paper you're looking at, okay? You guys see it? How many terms is that? 5 terms. What was the power? 4. When the item was squared, how many terms were there? 3. So the number of terms is always 1 more than the power. So how many terms does this have? 6. Number of terms is always 1 more than the power. If you need to write that down, write it down. Number of terms is always 1 more than the power. Okay. Now, they can ask you the problem one of 2 ways. They can ask you for the coefficient and give you the powers, or they can say, what is the third term? When it's terms, you have to do it differently. You have to do total minus specific. So what is the total? What is the total number of terms? And what specific one am I looking for? 3. So that means my first item will have a power of 3. My overall power is 5. So my y would get a 2. Yes, I'll do it again slowly. In this case, they gave us the powers. They may ask you for the third term, the fourth term. So when they ask you for term, you have to increase this by 1. And we get 6. You have to subtract the term you're looking for. So 6 minus 3 is 3. So the first term gets a power of 3. But my term powers must add up to the total powers. Sort of like when like your neutrons and protons, they have to balance out. Okay, so think of it that way. So it has to total out. So this gets a power of 2. Now that I have powers, I can write the code. So what is the first piece of the code? 5. What's the second part of the code? 3, which gives me 10. So that would be my coefficient. Okay? We're just doing simple ones today. Tomorrow we're going to add in some extra numbers. Okay? All right. So let's go back. We're going to go back. This one is identical to this problem over here. I would like you to try that one, and I would like you to try this one, the 2 ones I starred, okay? Okay. I'm going to start with this one down here because it's easier, okay? Did you do x9, y6? Did everyone get that? If not, speak up so I can help you, please. Don't be scared. I'm doing the bottom one. So x is 9, y is 6. I have not done the coefficient yet. Are we good with the powers? Okay. Can someone tell me the code? What's the code? And what do you get? 5,005? Thumbs up if we can handle that. I need thumbs up, somewhere in between. No, I don't have this. Yes, what's your question? No. We only do the subtraction when I ask you for the term. The like place term. First, second, third place. This actually gave you a power. Okay? So guys, this is a power. If I say the third term, the fourth, like finishing a race or a place, that's when you do total terms minus the place that I'm looking for, okay? So again, there's 2 sides. You have to see what style I asked it in, okay? Again, it's your first. We're going to practice again, okay? You're going to do a group activity tomorrow, okay? Here we go. Now, let's talk about this one. How many of you did X7, Y8. Be honest. X7, Y8. How many of you started first with X7, Y8? I know some people did. Okay? So then it should be 2 to the 8th. Yes? Okay, what is my code? What's my code? 15C7. What do you get? 35. That is not your coefficient. That is not your final coefficient. Correct. You are supposed to multiply it with 2 to the 8. I can't do x to the 7 because x is not a number. But I can do 2 to the 8th because it is a number. So in your calculator, 2 caret 8 times 6,435. What do you get? Now, let me get a calculator and make sure nobody lies to me today. Some of you gave me wrong answers the other day and I trusted you. Okay, you should have gotten 1, 6, 4, 7, 3, 6, 0. 1,647,360. I did 2 to the 8th power and then multiplied it by my 6,435. You guys know what the caret button is when I say caret? It's the insert for like English, yep, okay. All right, so, I want you to do this one now. And then I'm going to tell you about your homework. Your homework is to try the page 1. The 4 on the back is homework. Right now, I want you to finish this one right here, please. All right, for those of you who are curious that want to check your work, X9, 2 to the 6, 15C9, 5,005 times 2 to the 6th power, which is 64. What do we get? 320320. Did somebody else get that? Woo! Okay, what's homework again? It is, oh, I didn't copy it. Sorry. It is the back of that paper that I was just showing. It's 4 problems. It's 4 squares, yes? Awesome.